can see a welcome screen?
Yes, sir, it's visible, sir.
Okay.
Hello, Vinay. Good evening.
Hey, hi, Karthik. Good evening. I'm just going to switch on my video for a while and then we'll switch off. Suman, let me know, please, when you think we can begin.
6:05 we can begin, sir.
Saying 6:05. Okay.
Yes, sir. We'll wait for 5 minutes.
Suman, I'm thinking 6:05 will be too late given the content we have. So should we begin now?
Okay, sir.
Yeah, I think so. Let's keep moving because it will take some time in a few minutes in the beginning to set the context before the talk begins. So I think let's get going so that we have enough time to cover the topic that we want to cover today. So hello everyone. Good evening. Good evening once again, and I welcome everyone on behalf of AeroTHON 2025 organizing committee. I certainly have the privilege to welcome you all on the launch of the PDP session that are really aimed to provide you technical insights, programmatic insights, and we believe that that will help you in succeed not just in this event, but also in your professional career, professional journey. So before we really introduce the topic, I just wanted to take a minute or so to refresh you on what all we aim to bring to you as the helping hand as you are participating in this event. So I will share my screen once again, and probably I'll take you through the some of the I think hope you remember commitments we made that we will be helping you with. So hopefully you can see my screen again.
Yes, sir.
Okay. So I just wanted to refresh you on hopefully some of you who joined the very first our touch point meeting, we indicated some of the supports that we provide to the participants. So I've highlighted some of the green ones here. So again, refreshing on that. So we mentioned that time that as a part of this event, there will be a series of technical webinars and professional development programs that will be conducted for the participants, and mostly they will be emphasizing on the UAV design, build, certification, and everything. And that we aim to do during phase 1 and phase 2, so that we are launching today. In the process of that PDP and hand holding, as I mentioned last time, you will have chance to interact with the industry professionals. Some point in time, we'll talk to certification bodies, policy enabling bodies, many incubation centers in the country related to UAVs. So again, you will have those interactions all throughout in phase 1, phase 2. Some of that will be through the PDP session, and some of that when we interact during phase 1 and phase 2. Plus any other means of communication that works for us. The most important point I wanted to highlight here is as we handhold the participants during phase 1 and phase 2, thanks to all the sponsors, they have I would say very well curated modules, the technology licenses, they will be made available to you. So you should be able to utilize them, sharpen your hands, not just for this particular competition, for this competition vehicle, but anything that you think can help in your professional journey, professional career. Those tools will be helpful. So again, I want to take the opportunity to thank all the sponsors who are going to help you with the technology tools and licenses. And as I said, through our regular touch point meetings, we promise that we will bring all clarifications to you. There might be some questions we understand we might not have answer, but then we are trying to answer them as and when we can. And as a part of that, any questions that is coming across to us, we have set up a FAQ on the website. So my urge and request is that any point in time you have any question, first of all, please go to the FAQ of the website and see if you have the answer of your questions. If not, you can certainly post your questions to the SAE, and then SAE will work with the organizing committee and then we'll provide you the answers. But in some cases, as I said, please bear while we are trying to find that answer for your questions, especially in the case of logistics and other things. Lastly, during phase 2, this has been our tradition. So every team who are in phase 2, they will have a mentor coming from the industry, and you will be able to work with mentor more one-on-one. So this is something we have committed. We will do, and the reason I have highlighted green, most of them we have started delivering, and PDP we are beginning now. So with this refresh, I'm happy to bring to you the list of the PDPs that we have planned as of now. You see 15 numbers here. They are covering basically the aspects of design, the structural analysis, various types of aerodynamic, aeroelastic analysis, which are more during phase 1. But then as we go to phase 1, phase 2, there will be some aspects of AI, artificial intelligence, machine learning, deep learning, systems engineering, and any question for me? Okay, so just to give you a flavor, we're not going to talk about everything here, but just wanted to give you a flavor that this is something we have lined up, and this is not the end. This is not the last list of the PDP we are talking. This is something we have thought as of now based on the questions we have received so far versus our experience of the previous years. And then as and when we get input and insights from you, we'll build the PDP topic. So this is going to be a constant interactions means on technical side between the organizing committee to the students, and then a lot of industry speakers and sponsors are going to be really helping through this I would say structure. So again, I want to take the opportunity to thank all the sponsors, all the speakers, all the experts who will be delivering this talk. So my request to all the participating students is any point in time, if you feel need of any technical insights, please post that question to us, and then certainly we'll figure out a way whether the topic needs a PDP or a FAQ or what all means we can probably help you with. Before I introduce the speakers for today, just wanted to let you know that this list will be published on the event website. And as and when we present to you, we will be highlighting which company has presented. So this will be as a reference, and at any point in time, you'll be able to see that what are the PDPs available to you between now and phase 2. The last point before I get into introducing the speaker is the PDP sessions which we have planned, each available all throughout to everybody, all the students, whether you are going to phase 2 or not. So I think we are so glad that there is a hand-holding mechanism and it is available to everyone. So with this background, I will give a pause here and I'll stop sharing my screen, and then Suman, is there any way to mute the people?
Yes, I'm doing, sir.
Okay. Okay. So let me stop sharing, and I will take a couple of minutes to introduce the two very learned speakers we have with us today. So you saw the first list on the PDP that is going to be delivered by Hexagon today, and we have got two very experienced senior executives from Hexagon today with us. So I will begin talking about Sripati V. He is on the call. He is Director of Technology for Aerospace and Defense at Hexagon. And Sripati serves as a Director of Technology for Structures and Multiphysics in India and mostly in the Indo region. He comes with close to 25 years of experience in the areas of simulation and engineering, and he covers a broad aspect of structures and mechanical, for instance, aeroelasticity, structural dynamics, composites, advanced simulations. And then he works with the OEMs and defense, I would say defense OEMs particularly. He goes and sits in their factory, he goes and sits with their design centers, and he gives them advice that which way the technology can help them getting the product faster, more reliable. So basically, he like the way we are doing hand holding to the students, he handholds his customers and helps them adopting the technology. So he is not just resourceful, but very, I would say a person of high patience and passion both. His academics relates to Indian Institute of Science, and that's how he has a lot of interest on R&D and research, and he has a specialization and hands-on experience in drones and UAVs and satellites. So I think he is the best person to guide us. So with this, I will talk about the next speaker, but then As I learned, Sripati will not be speaking in this session as a speaker, and I know that for the reason because Sripati is the man of actions and man of less words. So he might be jumping in here for some questions, but then I learned that the regular talk will be delivered by Amit, who is with Hexagon for last more than 12 years. And Amit expertise includes design and engineering. And he works in the business development part of Hexagon, mostly covering the aerospace, machinery, and defense vertical that Hexagon supports. The good thing, Amit basically comes from the CAE background, and one of the any mechanical device we produce, durability is the most concerning thing, and Amit has the experience of handling durability aspect of design. So certainly we are lucky, to have, and we are lucky to get a chance to hear from him. Amit comes with aeronautic background uh, from his graduation degree, and he has mastered many tools, Patron, Nastran, Ditron, and many other tools that his company has been helping the industry. He has very core interest on finite element analysis, including linear, non-linear, model, and dynamic analysis. And like Sripati, Amit also has been hand-holding his clients, letting them be aware that which way Hexagon tools and technologies can help bringing their products faster into the market. So with this introduction, I will now hand over the session to the speakers. So over to you, Amit and Sripati.
Yeah, thank you so much, Vinay, for the quick introduction. Just let me share my screen.
So before Amit starts the session, Vinay, thanks a lot for a wonderful introduction for both of us. I think the interaction can be pretty much, I would say, one-on-one. I mean, like if they have any questions, all of you have questions, post in the chat. I will be there online to answer. And of course, we have done whatever we think is the right thing to communicate today. But if you feel anything better can happen, please come back and we will also, improvise on that. So with that, over to Amit.
So
Thank you,
can you
Sripati.
just confirm whether my screen is visible?
Yes, it is.
Yes.
Yes, Amit.
Yes, sir.
Okay. So it is good to go?
Yeah, we could see a screen.
Yeah.
Yes, sir. We can start.
Okay. Hello everyone, and welcome to today's session on the structural analysis of drone using MSc Nastran workflow with MSc Apex. My name is Amit Kumar, and I am Senior Technical Specialist at Hexagon. I specialize in structural simulation workflows, particularly focusing on integrating modern pre-post processing tool like MSc Apex and with powerful solvers like MSc Nastran. So today I will walk you through on how MSc Apex can significantly streamline structural analysis from geometry cleanup and meshing to setting up the simulation and interpreting the results using a practical drone model as our case study. Whether you are already using MSc tools or just getting started with simulation driven design, I hope this session gives you a clear insight into the latest capability and efficiencies Apex with Nastran and brings to the CAE workflow. So here is a quick overview of what we'll cover today. So we'll begin with a brief background of Hexagon Design and Engineering Division and its flagship brand MSc Software. We will explore the MSc full CAE product suite, highlighting how they support simulation-driven design. And then we'll learn how MSc Apex offers a modern, intuitive interface for the model preparation and analysis. We will discuss how Apex works seamlessly with MSc Nastran to provide a powerful end-to-end simulation workflow, and a look at a key principle behind MSc Apex like direct modeling, generative meshing, and scenario management. We will explain how simulation scenarios are set up and reuse, improving efficiency, and a quick overview of which Nastran solution types are now fully supported within the Apex. And we'll introduce the setup structure used for our drone example. And finally, we'll walk through a demo on setting up a linear static analysis of a drone using MSc Apex. So while explaining, if you have any queries or any any clarification is required, you can drop your questions in the chat, and we'll get back to you on once the the session over, or if we have time we can cover that in the here only. So, MSc Software is one of the 10 original software companies and a global leader in helping the product manufacturers to advance their engineering methods with simulation software and services. As trusted partner, MSc Software helps company to improve the quality, save time, and reduce the costs associated with uh, design and the test manufacturer products. So, where did MSc Nastran come from? So, company founded by Dr. Richard McNeil and Robert Schindler developed first program called SATSAM for SATSAM stands for Structural Analysis by Digital Simulation and Analog Methods. This was the forerunner of MSc flagship program, MSc Nastran, and MSc participates in NASA-sponsored project to develop a unified approach for the structural analysis, and that program become known as the Nastran. So, DNE portfolio. So this is our Hexagon portfolio.
Just to add,
Covers the
Nastran is called as NASA Structural Analysis. So it is basically named after the moon mission program for which the code was used, and this is the oldest original software company in the world, alongside of Microsoft, Cisco, and others. So just to add to that, Amit, yeah, for all the others benefit.
thanks, Ripi. So, Hexagon DNE portfolio covers full spectrum of physics. So when we talk about structural analysis, we have a MSc Nastran and MSc Apex. In multi-body dynamics using atoms, when you are working with the scenario non-linear and explicit simulation with, we have a Mark and Ditran. When you are dealing with the computational fluid dynamics, so we have a product called as a Cradle. In that, SC flow and the SC stream. We also have a solutions for the manufacturing process simulation and material modeling and data, plus optimization and AI driven design through the CA fatigue and the COSIM. So all tools are being unified under a modern integrated platform, offering a connected simulation experience, reducing time, improving accuracy, and supporting the smarter product development. In summary, the top and bottom row of tools are the typically solution address specific application like manufacturing, transmission system, composite material, virtual test driving, or a physical phenomenon like structural behavior, fluid dynamics, fatigue, and acoustic. In middle layer, you can find out the tools related to the pre and post processing activities, uh, to process and data management, co-simulation between multiple tools, and machine learning that can be applied in the conjunction with any of the solution from top and bottom row. So, Hexagon's multiphysics platform empowers engineer to simulate the structural, thermal, fluid, and acoustic phenomena within a unified environment. By integrating tools like MSc Apex, Nastran, Cradle CFD, and more, users can streamline the complex workflow, reducing design cycle, ensure the accurate real-world simulation across all the domains in one seamless ecosystem. So the industry is becoming more, reliant on virtual prototyping to help design their products. If you look into the process involved from having a CAD geometry to having a simulation results for the decision making, we can easily see where the pre and post processing steps fit in. Starting with the CAD geometry produced during the design phase, and the FEA analyst would go through all these stages such as geometry cleanup, meshing, defining the model, setting up the analysis, submitting the model to the solver, and retrieving, visualizing, and the extraction of the result. The strength of MSc Apex is that has a comprehensive suite of tools designed to make the whole CAD to result process effortless. So MSc Apex has a lot of flexibility as to how to what extent it is used, and it has both generative and regenerative behaviors. User can utilize the wide range of CAD generation tools to create a model from scratch. Alternatively, in industry, it is quite often the case that CAD model is available to use to save and redrawing the geometry from scratch. To accommodate different CAD software of a choice of stream, MSc Apex can import more than 12 geometry files types, including ACIS, Inventor, Palosolid, IGS, Step, SolidWorks, CATIA, ProE, and UG. Users can also import the mesh from the legacy FE model, visualize and integrate and validate the model. And you can re-extract a CAD model from the mesh and make the modification and convert from one analysis type to another and change the analysis setting. In easy to use graphic user interface, users can reuse, repurpose, and redesign the orphan mesh model. Changes to object upstream are automatically updated downstream. Another powerful capability of Apex has its unit conversions. In Apex, a model can be imported in one unit system, work in a different unit system, and export in the another unit system. So the conversions all done automatically by simply specifying the desired unit system at any stage. The Apex has strong CAD mesh, CAD result capabilities. It has a geometry cleanup, repair tools, powerful mid-surfacing tools, robust in-built advanced meshing algorithm, which produce high quality meshes. The most of the powerful features of Apex are the model organization tools such as dependence manager and modules. So we'll discuss that in coming slides. MSc Apex has a capability which can be, help customer to improve productivity. An example, this is a visualization checkers. It can be used to element quality, interaction, connectors, shell thickness, shell normal, composite material properties can be turned on and turn off. Users can further leverage the scripting capabilities to develop the customized tool to meet their specific needs. Another strength of Apex is its usability. And with MSc, Apex, and Nastran together offer a powerful, tightly integrated simulation environment. Users can build and validate models in Apex, then seamlessly submit and monitor the simulation in the MSc Nastran, all within the same user, all within a same user interface, basically. This integration eliminates the file translation errors, reduce the turnaround time, and it supports advanced workflows like non-linear. Then when you are working on the dynamic or you are looking for the optimization analysis, and the future lies in unified simulation, and MSc Apex and Nastran is the leading way. To unlock the full potential of simulation by combining MSc Apex intuitive modeling and pre and post processing capability with robust solver, which is MSc Nastran, engineers can benefit from the reduced setup time. So enhance accuracy and seamless transition from design to simulation driven decisions. MSc Nastran continues to, uh, evolve through the sustained investment in its solver technologies, enhancing the performance, scalability, and the accuracy. Recent advancement includes the faster solution times, which is very much important, improved the support for the nonlinear dynamic analysis, and enhance the contact algorithm. And it also, having expanded material modeling capabilities. This development ensures MSc Nastran remains a trusted and future-ready solver for a mission-critical engineering simulation across the industries. MSc Apex delivers the advanced meshing capabilities that combine automation with full user control, enable high quality analysis, ready meshes even for the complex geometries, with powerful tools for mid surfacing, automatic cleanup, local refinement, adaptive meshing. User can achieve optimal element quality and accuracy, whether you are working with the solid, shells, or mixed mesh types. Apex ensures that precision and versatility across a wide range of simulation scenarios. Accelerate the product development with MSc Nastran advanced dynamic capabilities covering modal, transient, frequency response, and the random vibration analysis. Combined with MSc Apex modeling and the pre-processing, uh, engineers can rapidly iterate the design, assess the performance under the real world dynamic loads, and make data driven decision early in the design cycle. So that makes your design accurate, and it gives you a good life. This streamlined workflow empowers the team to deliver the robust, high performing products and faster with the greater confidence. So, what is MSc Apex? So basically, it is the latest generation CAE pre and post processor, a game-changing user experience, I can say, allowing massive efficiency gains. So whatever time you're spending in, generating the mid surface, meshing, assigning the properties, so it gives you, you can save a lot of time in that. It is having a strong set of geometry modification and repair tools with the latest meshing algorithm. So when you are importing the geometry, you don't need to depend on the design engineers. So you can directly modify and edit your geometry within the Apex, and you can mesh it. It is having a integrated solver as well, and it supports external Nastran fully now. It is very easy to learn. It is having a inbuilt help videos and tooltips. So like Google style search tool, it is within the inside the tool, and with the help of that you can easily learn that tool, and you can do the automation and customization workflows, which will be helpful for the powerful scripting framework. And it supports all your Nastran workflows. So here you can see in this slide, so whatever the job, for example, you have meshed the component and you want to change the design, and when you are doing that modification, you don't need to remesh that component. So it gets, auto mesh regeneration, it is there. It is having an intuitive CAD and mesh creation. You just need to, pull push you have to do, and by that you can change your design within quick time. Easy way for the mid surface extraction, and lots of integrated tutorials and videos are available. So very short videos which can guide you to learn that tool, and you don't need a expertise on that. So basically, as you are new to this tool, you can learn quickly and start working by using this tool. It is having a brilliant functions, I can say. You can do the sketching at certain level, you can do the geometry repair, you have a exploded view, you can do the defeaturing. For example, you don't want some features which is created by the designer, that in a one shot or in couple of clicks you can remove all that unwanted features. You can revolve, extrude, sweep, loafing, all that you can do here within the Apex. And it is having a capability to do the post processing in within itself. Also, you can do the accurate hex meshing. Lot of engineers face challenges to convert the model into the hex mesh, but in Apex there are few tools, we can say, which can help you to generate the accurate meshing. And you can also do the feature based meshing, so you can decide the what feature, how you want mesh, so that all you can define in the Apex itself. And you can generative mesh as a geometry you can do. Like we are all are from the working on the drones. So when you are working on the composite modeling, so it is very easy to model here. You can add the material, you can build your inbuilt material library, you can lay up the creation, and result viewing also you can do here within the MSc Apex. A standout feature in MSc Apex is modules capability. To purpose the build this capability to help the engineering team efficiently manage the large and complex assembly models. In modern product development, different team design separate components that are later assembled for the full system simulation, right? So traditionally assembling these models required a meticulous management of node elements and ID numbering to avoid the conflicts. The key benefit of MSc Apex modules here is it supports Nastran modules, enabling the full pre and post processing workflow, including the module connections. Easily you can import existing include files structures and convert them into the Apex module structure. You can mirror or translate primary modules to create a secondary instance, so that is also very much possible for the repeated geometry. And it is very, you can manage safely. There will be no duplicate IDs across the modules within the same assembly, and you can run and debug the modules individually and improving the troubleshooting and the workflow efficiency. View the results as per the modules, not like a whole assembly. If you want to go with the module, that also it is possible, and you can measure across the entire assembly the results. So both the things are possible here using the Apex. One more thing is Apex is transforming simulation workflows by offering a highly adaptable and developer friendly platform. It is not just a tool, it is an evolving engineering partner. uh, it supports extensively APIs, access across the geometry creation, meshing, simulation setup, and the post-processing. Automated repetitive tasks to boost productivity and reduce the human error. You can accelerate the complex workflows and develop the custom tools tailored to your team needs. So by doing this activity, you can develop your own automated micros and you can do the analysis. So the rich library of example scripts are available in the help, so engineers can get started quickly, backed by the comprehensive training, documentation, and the professional service for the effective deployment. The frequently used scripts are productized into the core functionalities. Scripts sandboxing enables to experimentation, iteration, and the refinement of the workflows. MSc Apex empowers engineers to streamline the workflows, test and innovative the confidence, influence the platform innovation, and by merging this automation with agility, MSc Apex sets a new standard for the simulation-driven design. So, additional to that, Apex is having some unique capabilities. You can do unlimited undos and redos. You can do the use the 2D sketcher. You have an analysis readiness where you can check your setups, whether it is what are the steps you have created, whether it is meshing, you have properly assigned the properties or not, so that all you can check before submitting to the run, so it helps you to avoid the error. And one more unique feature is that if you are having an existing mesh but you don't have a CAD, so from mesh to CAD also you can create. So that is something unique capabilities Apex is having. And if you are working on the assembly and there is only a particular part you want to replace in the whole assembly, So you don't need to work on the whole assembly, only the one single part you can replace and it will get automatically meshed and the connection will be established in that. So these are the unique capabilities Apex is having. So now let's talk about the Nastran analysis decks. Okay, so a user can create a multiple scenarios. Basically, we can scenarios means it consists linear, normal mode, linear buckling analysis, frequency response, transient, and non-linear with the implicit transient. So all scenarios can be accessed from the study tab. You can just go to study, create a scenario, and you can select which type of analysis you want to conduct. So it is very easy. In Apex, you can set the pre-release scenario. You can check that. So for example, few people want to set up for the aero elasticity or aerodynamic flutter setup. So these pre-release display scenarios are also available, and you can this scenarios configuration tool now display many more scenarios type. So you can see here that list is available here. So how to create the scenario? So once a scenario is created, it displays in the study tab in a hierarchical collection. The structure of hierarchy is different depending on the solution sequence. So for example, when you are selecting the linear static analysis, the structure will be different. When you're shifting from the linear to dynamic, then it will change the structure. It is not like that all the steps getting changed, but there are a few certain requirement which is required for the another analysis setup. So for that, additional tabs will be added in the scenario tab. And what are the case control commands that are applicable to scenario that can be accessed from the scenario tree. So in once you have created the scenario, inside that you can create a multiple load cases. And if you are having the multiple load cases with the multiple loads, so you don't need to create a different window for that. You can create a different scenario within the same window, and the UI can complete the command, and you can you know uh, set up all the load combination for the analysis. So now I will take you through one of the drone workflow which can be helpful for you in future. So here we are going to set up the analysis, and we'll do the linear static analysis here for the drone. So I will import the geometry. So it is available in the XT format. Just click on the import. So it's loading the model. So you can see here there is a drone frame available, and you can set the unit parameters. So it is having a inbuilt library of unit system where it is consistent and inconsistent unit systems are available. You can set up that. I'm just showing you the components. So it is having a rotor arm, supported legs, frame plates, and the fastener which are connecting together. So here now the fastener we don't require. We will directly create a contacts. So we'll delete that fastener. Now we'll go for the mesh. So you can see here I'm selecting the arm. I will define the mesh size, and I will go with the linear tetra element meshing. And in later on, if you want, you can go with the second order meshing as well for the better accuracy. So I will select the next arm. So all the 4 arms are meshed now. Now I will mesh all the support legs, and you can select in a one at a time. You don't need to select one by one. You can select, and you can see here the mesh quality, and the it is capturing all the required features automatically. So I will just mesh the frame plates. Now I will define the material and properties. So you can name the material which you are going to apply to the specific component. So you need Young elastic modulus, Poisson's ratio, and density you can define here. Also, if you are working on you want to add some non-linear material, that also you can add here. So I will add one more material. You can create your own material library also in the Apex. So that will, you can keep as your own material library by default. Now I will go and assign the element property. So first I will create for the rotor arm. I will select the plastic material for the arm, and I will just go to assign and select the arms. So it will get automatically updated. And that same thing you can see in the model tree. Same the remaining components. So supported legs, I will select the plastic material for that also and assign the property for the all 4 legs. Now next is the frame plates. So just rename that. So it will be easy for you to identify which material is applied to which component. And here for the plates, I will apply the aluminum. So you can see here in the model tree, the 3 properties are created. So your model is ready now. So we'll go to interaction palette. You can directly create the select all the components, and you can create a contact. You can manually also define the properties, whether you want segment to segment or segment to node, or the contact tolerance also you can define manually. So now I will go with the auto method, and I will select all the components. So now it will automatically auto detect the contact between all the components, and you can see in the model tree the interaction is created. So there are total 16 interaction between the components, and you can see here the deform body is also created.
Sorry to interrupt. Suman, could you please mute everyone? Students, like if
So
you
now
have any questions, please unmute yourself. Otherwise, please be
I will
muted.
create a contact table for the all the interaction. So it will be grouped and created into the single table. So you can see that that is also going to appear in the model tree. Now you have done the meshing, connections and contacts. So you can re-verify whether it is, connected, created properly. Now here we will going to apply the motor lift force on each arm. So here this whatever the 4 holes are there it is going to mount that motor. So I will create a force, lifting force of that particular motor. You can define the value. So I will take as a 25 Newton here and define the scale factor. So 1. So you can do the vice versa. So scale factor you can make a 1 and the force you can make a 25. Now here I will select the remote method which will automatically create the rigid. You have to switch off the auto lightning so you can select all 4 holes. So you can select that and just I'm dragging that up little up the rigid. Same load I will create on the other arms also.
Sir, your screen was not visible, sir.
Is it?
Yes, sir.
Just lost a minute back. You can just try resharing.
Oh, okay. Just let me share it again. Is it visible now?
Yes, it is.
So here I'm creating the applying the motor load. So all 4 arms having the 4 motors. So each arm I will apply the 25 Newton motor force. You can add the mass of the remaining component at the center of the drone. So where the battery weight and the remaining component weight also can be added. So now on the third arm. So once you select all the 4 location where I'm trying to apply the force, and once you press the middle mouse button, it will automatically calculate the center and you just need to apply the force on that location. So that is very easy. You don't need to require a CG of that particular motor. Or if you have a CG, then you can create a point and select that point as well. So both the way you can do. So now you can see here the 4 forces are created. I'm just renaming this. To motor lift 1. So you have 4 motor lift forces on the 4 location, 4 arms. Now the another thing is like we have to consider all the 4 loads in a single step, right? So here you have to create a load combination where you can select the all 4 loads, or if you want to make a combination of different cases, so that also you can make a different load combination and select that into the your sub case. So that you can do. So you can see here that load combination I have created for this all 4 loads, and you can re-verify whether all forces are considered or not. Now I will create a constraints. So the bottom of lake I will constrain. So you just need to select the surface. Automatically it will select all the nodes and it will constrain. You don't need to select manually. So all 4 constraints are created. Now same way for constraint also you have to create the constraint combination. So you can see that all 4 constraint list is there. So you have to make it active and just create the load combination, which will be written in your deck later on. Now your all modeling is done here. Model is ready with the all loads and boundary condition. We will go to just you need to set up the environment. So Apex is having two solver types here. So it is having an integrated solver as well as the external Nastran. So due to some limitations, we are going to use external Nastran. And you can also use the cloud computing. So we have a Nexus compute where you can run your analysis on the cloud. So that option is also available. So right now we are going to use the external Nastran, and we'll just add the path of the Nastran here. So it will take directly. Okay. So I'm just going to the installation directory, Nastran, and I will just select the exe path. And I will just paste here. So it will directly takes the external Nastran. And the directory where you want to run, so that also you can select. So it will help you to wherever the space is available, that location you can set your path and it will complete the run on that location. Because when it is solving, it requires a lot of space. Okay. And because in background it generates the file which later it will be get deleted once the run is completed. So you should have a free space in that, and you can set up the remaining solver settings. So the solver max memory, buffer size, buffer pool. So this you can go with the auto as well as you can define manually. So that settings you can go to options and you have to go to Nastran compute environment and the external Nastran. So just say okay once that setting is done. Now go to study tab, right click and create the scenario. So here, as I mentioned earlier, you have you can select the solution type and you can add to your analysis name and description, and you can select the type of analysis which you are going to conduct. So here you have a list of solution sequences. So, and also if you want to work on create a multiple load cases, that can be created here, and say okay. So you can see this tree is appearing here in the below the scenario. So you have to go the step by step. First, you have to associate your model which you have created. So the benefit of Apex is whether you want to work on the assembly or you want to run the analysis on the component level. So you can select, that here. So it is not like that you cannot do the component level analysis. That also can be selected. Then go to model configuration. If you are having any non-structural mass and all, that can be added here. Now go to load case. Here you can select the your constraints and the loads what you are going to apply for this model. So you can see here, if you want to create multiple load cases, you can create here and select that particular load. Right now we are considering all the 4 motor loads and the 4 leg constraint. So that combination we are going to use here. So for that we have created already the constraint combination. So here I will select the constraint combination. So you can select any, if you are doing the multiple load cases with the different cases. So that also you can select. Same for the loads. I will go. So if you want to add some stiffness singularities, so that you can select. You have advanced properties where you want to print the singularities or you don't want to print. So that stuff can be done here. And also if you want to add artificial support, that can be added here. So right now we are just selecting the constraint and the loads. So here also whichever the load you want, that can be selected for that particular load case. Right now I'm going to select the load combination, which consisting all the 4 loads. And if you want to add some temperature or axisymmetric conditions, so that can also be possible to add. So you just need to recheck whether that is active. So here constraint and the static load I'm keeping active and the temperature I'm leaving. So as of now there is no temperature load, and say apply. So after that we'll go to contact and glue. Right click and go to properties. You have a different contact controls and detection contact activation method. So here I will select the contact pairs or table which is already created, but you have options where you can automatically select the body, or if you want to consider all bodies, so that options are also available. So here also all interaction are going to appear. From that I'm going to select the contact table. So it consists all the interactions, what are the contacts we have created, and say OK. You have other settings also. So whether if you are working on the sliding contact, or you want to define some contact method, whether it is node to segment or segment to segment, so that can be selected here. Then if you want to add friction properties for the sliding contact or permanent non-linear glue contact, so that properties can be added. Also the detection method thresholds can be added here, so that tolerance it will consider, and all it will be written in the bc para command in your deck. So these are the different properties which can be added later if required. So now I will go to output control. Here again you have different options. So you can add parameters, or the what is the maximum number of output lines is required, printed lines per page. So that you can consider as a default, or if you want, that can be edited. Now next to output request. So here the list of outputs are there. So based on your requirement or your interest, you can select. So we can select constraint forces, displacement, element stresses, and if you want to plot punch, so that can be changed. Also, if you want different type of based on the stress theory, so you can select which you want stresses, one masses you want, or max principal you want. So that can be selected as a output and say okay. Another thing is the parameters and system cells. So you can go here and you can select the case control. You can create a param set. For example, here I'm adding auto MPC mset. So you just say no in place of yes and go to bulk data if you want to add any entry and just say okay. So that parameters can be added here. So you can see here that load case 1 auto mset is added, and you can select that case control to that particular load case. So here auto mset is activated. Then once the run is submitted, you can go and check the simulation status in the simulation tab. And here there are the scenario export settings are there. If you want to add any command in the bulk data section or case control section, that can be added here. There are also some simulation settings based on the analysis scenario. For example, you are working on the non-linear analysis, so that settings are there. Then if you want to control the rigid element, so that things are there. And there are some parameters for the model check, so FEM check, ground check, weight check, so that you can activate if required, or you can go with the by default values also. And then whatever the unit system you want to consider for the solving, so that also can be selected here. And what is the result format you are looking for, the HDFI, OP2, XDB, so that you can select. And you can select whether you want in the white field or you want hierarchical right, so that can be selected here. So this is the different output files are formats are available. So based on the requirement, you can select that one. Say apply, okay. Now load case, you can just double click and you can see what are the loads and constraints are selected. You can re-verify, and if you want to add any additional load case, so that you can add here by just clicking right and just rename that one. And what are the loading condition you want to consider, that you can add. Now just go to analysis scenario, right click and run the simulation. So I have submitted. You can see that scenario in a green color. That means it is solving. Now and you can directly jump to the post process and you can see the result. So due to the lifting motor lifting force, what is the reactions coming on your rotor arms, so that you can see. So these are the stress values and this is the deflection due to that force. And you can you can create a multiple windows and compare the results, and you can just take the snap and you can prepare the reports as well. And also you can do the animation and you can add that to your report. So what different type of stress and the displacement in particular direction, what is the displacement, that you can plot here. So this is how easy way to model and do the analysis in Apex. Okay. So now how you can learn this? So it is inbuilt. You have the documentation and tutorials. So there all type of analysis sequence examples are available. You can just go to that particular requirement, and you can go through the tutorial and start working on that. Also, you have an online Nexus Academy where you can just you have a online help, and you can get a help from that as well. So here different examples are available with different type of analysis, and you can make a use of that and quickly learn and complete the analysis. Also, you have a this is something very useful for the prospective uh, the MSc Nastan and Apex 30 days free trial is available. New user can register for it, and you can go to Hexagon website, and no prior license agreement or anything is required. Just go and enter some basic details, and you can get the 30 days free trial software there. And there are also tutorials and study material is available for the additional to that. There are some training courses are also available, our own courses as well as those who provided by our partner. So that all are available in the Nexus Academy. It is fully integrated with MSc Nastan, and the static, dynamic, buckling analysis are available on this trial version. So to summarize, MSc Apex is an agile CAE pre and post processor with a modern intuitive user experience. The software has advanced CAD to FEM features that have been designed for specifically to the help customer tackle time consuming and the labor intensive tasks, thereby remove the bottlenecks in the simulation process. Another key strength of MSc Apex is that it is now one of the most comprehensive pre-processor for MSc Nastan, in particular to Solve 400, which is for the non-linear analysis. Okay, and the number of MSc Nastan keywords supported by software is almost 95% now, and it is continuously increasing to fully. And as we move into the future, automation and customizations are two essential requirements for the pre and post processor, which is Apex is designed well for. And MSc Apex has micro recording capabilities and the Python based APIs for both pre and post processing tasks, allowing standardization and increase the productivity. Additional to that, you have the cloud support also, where you can submit the runs and you can utilize the cloud services as well. So thank you so much for your additional attention, and please do not hesitate to ask if you have any questions, please ask us. And if you want to contact, you can just drop your details in the chat, and you can request that. So thank you so much for attending this session.
Thank you so much, Mr. Amit Kumar. And I'm sure students would have learned a lot of design principles and also about the packages, the software packages by Hexagon, mainly the MSc Astron and the Apex. So I'm sure that students would make use of these softwares, and not only that, like the package which you offered as a free trial version, that gonna help all the students. So without any premium membership. So thank you so much for your insights, and it was a great lecture. And we are going to have the consecutive sessions again on the some of the PDP topics. So we would like to thank Hexagon for their continuous support for AeroTHON 2020, for AeroTHON as a whole, and also to a special mention to Mr. Sripadi for his support and all the effort in which we are bringing this PDP series into shape. So thank you so much. If students, if you have any questions, so we made note of all the questions which you posted on chat. So definitely we will take from here, and then we will get answers for them. So if you have any special questions to Mr. Amit Kumar, you can unmute yourself and ask. Then we can hand over to Sripadi for closing remarks if he has any. Thanks once again, Amit.
Yeah, thank you. Thank you so much.
Okay, all right. So, Sripadi, are you there on the call?
No, sir.
Okay. All right. So, thanks once again, Amit Kumar. We will touch base with you again. And if students have any questions, I will pass it to you. And also, we will try to have a special link in our AeroTHON website so that all the information and the content related to the PDP series or any information which you would like to share with the students, that would be made available to the students in the AeroTHON website. So yeah, thanks once again. Thanks everyone for participating. So the next week, I mean the May 3rd, that is coming Saturday, you are going to have another PDP session. So stay tuned. Thank you.
Thank you. Thank you so much, everyone, for joining this session.
Thank you, sir. Thank you so much.